Hi, Alexander Reppening here. I want to demonstrate you quickly how Ruler works to write a very simple program in this Pac-Man game. So one of the guiding principles or philosophy is essentially that we should support with computational thinking tool the notion of pragmatics, and by that I mean essentially the study of what programs mean in particular situations. So some of the tools that we looked at phones, they have this idea of an interface which either shows you the world that you're about to program or the program itself. So it's almost a certain tunnel vision. And that's not good. I want to be able to select objects, like in this case the Pac-Man or the Ghost. I want to be able to see the program and the world at the same time to understand what I'm actually programming and to understand what the situation really is, and to have the computational thinking tool help me to understand how I can use the situation or how I can change it. So let's start with the Pac-Man. In the first version, we tried to program the Pac-Man to make it go from where it is right now to the cherries on the right. We're not going to do the whole thing, but essentially I can write a rule without a condition, and I'm tapping here to select actions. Now the Pac-Man is turning into a ghost, the genie, which I can control with these actions that I have in this palette. I'm going to first rotate the ghost to the right. Now I have a choice of actions to move the Pac-Man. I can either use absolute coordinates to move in the world, or I can use turtle moves to move relatively. So I'm going to move forward in the direction that I'm facing, going forward one step, going forward two steps. And on the left hand side you see that not only is the program accumulating, but we're also seeing in the world that they're executed with the ghost, with the genie. Now I need to make a left turn, I go forward, I make a right turn again, I go forward, etc., etc. So you can see this is the first version perhaps of our program, but of course, it's not a very general algorithm to really solve the way the Pac-Man could go through the maze at any or of any different kind of maze. So let's actually start this again with a completely different idea. So I'm going to reset this. I'm going to go back to the Pac-Man, and now I'm going to program essentially the behavior of an arbitrary maze algorithm, the one where I use the right hand rule to always follow the wall. So what I would need to do is, at the moment, I would have to say, well, the Pac-Man doesn't actually see a wall to the right. So the first thing it should do, it should realize that there is no wall to the right. So it should turn right and make one step. So I'm going to select here the Pac-Man. I'm going to look for my turtle C conditions, and I can see to my right there is a ground. So I'm going to pick that one. And if that's the case, so that's currently green. If that's the case, I can turn right and move one step in the direction. So we could now execute this one step. Let's see. So the Pac-Man is going forward, but you can see it's already stuck. So with this rule, we're not going to get any further. We also need to have a rule that if the Pac-Man cannot turn to the right, it needs to go straight. So again, I'm going to look for my relative turtle command. So if I see a ground ahead of me, then I'm going to move straight forward. So let's keep going. So the Pac-Man can go now further and further. You can see it still annotates the rules. Now it could turn to the right. It keeps going, but now it's stuck. Neither of these two rules is going to apply, so they're both red. So that's the pragmatics. Now I need to say, well, in this particular case I could turn. I need to turn. I can turn 180, but it's actually sufficient just to turn 90 degrees. So I turn 90 degrees to the left. Now let's see, etc., etc. So that's the program now, and we can see at each step the program is being annotated, showing us what it would actually do. Or we can just run the program now. And there it made it to the cherry.